us try to see the demonstrative example on how distribution of mass plays an important role for us to understand rotational inertia. So we can see this pen. It is very easy for me to rotate the pen, but observe very carefully, the same pen, if I tilt it like this and now I rotate, it becomes even more easy for me to rotate. Why is it even more easy to rotate? Because in this case, the axis is passing through the center, the distribution of mass is closer. So it is very easy for us to rotate the body. But on the other hand, if I rotate the body like this, the distribution of mass is away from the axis of rotation. That means it is slightly more difficult. And in the case of rod, the distribution is even more far away. That means it is even more difficult for us to rotate the body. So, rotational inertia majorly depends on two things. Number one, mass. Number two, distribution of mass. And this rotational inertia is also called as moment of inertia. So let us try to understand what are the factors affecting moment of inertia. Factors affecting moment of inertia, number one, mass. If more is the mass of a body, then more will be the moment of inertia or rotational inertia. If less is the mass of the body, then less will be the rotational inertia or moment of inertia. What else are the factors affecting? Number two, distribution of mass. If the distribution of mass is away from the axis of rotation, then the moment of inertia will be more. And if the distribution of mass is near the axis of rotation, that means the body is closer to the axis, then the moment of inertia will be less. Point number three, moment of inertia also depends on position and orientation of axis of rotation. Position of axis plays a very important role. Like this, observe. For this pen, if I am rotating from the middle, the distribution of mass is happening till here, till here. That means distribution is near only. But if I take the same pen and rotate about the end of the pen, then the distribution is more away. Why is it more away? Because the mass is further away from the axis. So it will have tendency to have more moment of inertia. Obviously, it becomes difficult for us to rotate like this. So that means moment of inertia depends on position and orientation of axis of rotation as well. After understanding the factors affecting and significance of moment of inertia, as well as understanding what is moment of inertia dependent on, now let us move ahead towards defining moment of inertia and its formula. Moment of inertia is defined as the product of mass and square of the distance from the axis of rotation. Moment of inertia is defined as the product of mass and square of the distance from the axis of rotation. That formula comes out to be I is equal to mr square, where m is mass and r is the distance from the axis of rotation. Let us now write down the formulas for moment of inertia. So as we discussed in the definition, suppose say if there is a single mass, let us call that mass as m, it is rotating about an axis of rotation. So this is the path of the mass m. It is rotating about an axis of rotation which is passing like this. Let us assume that the distance of mass from the axis of rotation is r. So the moment of inertia is given by a very simple formula, that is mr square. So moment of inertia is the product of mass and square of this perpendicular distance from the axis of rotation. So it is the product of mass and square of this perpendicular distance from the axis of rotation. So what will be the SI unit of moment of inertia? Let us very simply put this. What will be the SI unit? So mass is kg, distance square is meter square. So SI unit will come out to be kg meter square. The dimension will be m1, L2, T0. So this is SI unit in dimension of moment of inertia. So moment of inertia can be defined in three types based on different types of system. Like number one, for a single particle system. Suppose say there is only one particle of mass m which is present at a distance r from the axis of rotation. So this mass m is rotating about the axis of rotation. The moment of inertia for this mass will be given by I is equal to mr square. Very simple formula, very easy formula. In the similar way, number 2 is for a discrete system. Discrete system, as we already have learned, means discontinuous system. That means there can be n number of particles which are present. So there are n number of particles. Each mass m1 is suppose at a distance r1 from the axis of rotation. So mass m1 is at a distance r1 from the axis of rotation. m2 is at a distance r2 up till mn is at a distance rn from the axis of rotation. Because there are so many masses rotating about the axis of rotation, we now finally conclude the moment of inertia to be I is equal to m1 r1 square plus m2 r2 square up till mn rn square. That means the total moment of inertia can be given as summation of mr square basically, but that summation can be written as summation miri square, where I indicates from 1 to n. That means we are adding from 1 to n. So we get the final formula, moment of inertia I is equal to summation I is equal to 1 to n miri square for a discrete system. But at the same time, the third type of system, which is a very essential system, is called as continuous body system. So suppose there is a continuous rigid body. The rigid body is rotating about a given axis. If a rigid body is rotating about a given axis, how do we find its net moment of inertia? So for a rigid body, let us not consider a complete complex body. Rather, let us consider a very small particle. Let us say that that very small particle has a mass dm. That mass dm is at a particular distance r from the axis of rotation. So now that one single particle dm, when it is rotating about the axis of rotation, it will have a small moment of inertia which will be given by di is equal to dm into r square. Because now we have this small moment of inertia, di is equal to dm into r square, we can find the net moment of inertia which is given by capital I, which is equal to integration of small moment of inertia. So I is equal to integration of dm into r square, and that is how we will be able to find the moment of inertia for a continuous body. So with the help of this session, we understood what is inertia in linear motion, how do we define rotational or moment of inertia, and what are the different formula and significance of moment of inertia.